A binomial distribution is a probability distribution in which each trial can be thought of in terms of either success or failure. P is the probability of success, and Q is the probability of failure. So to calculate the probability that you get X successes in N trials, you use this formula. The probability of X successes is N choose X times P to the exponent X times Q to the exponent N minus X. And remember, N is the number of trials, X is the number of successes, P is the probability of success, and Q is the probability of failure. So here's an example. You're trying to roll a 5 on a 6-sided die. You plan to roll the die 10 times and wonder what the probability is of rolling a 5 3 times. So success in this case is rolling a 5. In the question it says you plan to roll the die 10 times, so we know we're going to have 10 trials. We also know that we're wondering what is the probability of rolling a 5 3 times, so that means we're looking for 3 successes. The probability of success is just the probability of rolling a 5, which for a 6-sided die, there's one way to roll a 5 out of 6 possible outcomes. Since the probability of success is 1/6, the probability of failure is 5/6. So we'll start with the probability formula for a binomial distribution. And I want to have the probability of 3 successes. And I'll just plug in my numbers that I already went through. So after I plug all that into my calculator, I get the probability of rolling a 5 3 times is 0.155, or 15.5%. Here's another example. A basketball player can sink free throws 87% of the time. If he takes 6 free throws in the next game, what is the probability he sinks at least 5 of them? So we know success is considered to be sinking a free throw. And we know from the question he can sink free throws 87% of the time, so the probability of success is 0.87. Which means that the probability of failure is 0.13. He's taking 6 free throws, so N is 6. And so in the question it says, what's the probability that he sinks at least 5 of the 6 shots? So I'm going to write that like this, the probability that X is greater than or equal to 5. So since it's at least 5, he could make 5 shots, or he could make 6 shots. So we have to do the probability that he makes 5 successes plus the probability that he makes 6 successes. So I'll just use that probability formula for binomial distribution for each. So the probability that he makes 5 shots plus the probability that he makes 6 shots. So if you do that in your calculator, you should end up with this probability, which means there's an 82.24% probability that he'll sink at least 5 of his 6 shots. Now for the same situation, there's another question that can arise. So how many free throws should he expect to sink if he takes 10 shots? This is the formula for the expected number of successes. We know that N is 10 because he's taking 10 shots, and the probability of success is 0.87. So when you do the math, you get a value of 8.7. So you could write he should expect to sink 8.7% of his shots. But since you can't get 0.7 of a shot in, A more realistic answer would be he should expect to sink 8 or 9 of his shots.